Laguna Tools. I'm Bob Alsop, or as they call me around here, Router Bob, and we've got a great video for you. I'm really excited about this, and I'll tell you why. We've watched the SmartShop product line really take off, and it's tremendously successful. It's a great value for the customers, and there's a natural evolution, and this machine represents that. This is a SmartShop MT, and MT stands for multiple tools. We took the basic SmartShop 2 concept, and that is a one-piece all-welded frame with very good components, so you get really great edge finishes. What we wanted to do, though, was to add more capability to it. So instead of maybe having a CNC with a tool changer, we also wanted to have other functionality on it. And of course, we kept the B&R controller as part of the package because it's based on the SmartShop 2 design. The SmartShop MT has a B&R controller that we developed, and it's really interesting. We developed this to make it simple to use. It has all the power of almost any machine control, yet we created an operational format that makes it easy for typical people that you might hire to run the machine. Now, because it's an MT and it controls more heads and more axes, then it's a little bit more sophisticated, but the operation's still just as simple. Okay, what makes this an MT model is simply this. You have a larger tool plate. All right, that larger tool plate gives us the ability to put more than just a router head on here. This machine has a router head. This could also be an automatic tool changer head if you wanted. But we've also got 3 other positions here. Now, 2 of those, we basically put 2 new pieces of technology that we developed. One is an oscillating saw that operates tangentially, which means it has a 4th axis. And we also have a tangential knife that operates with a 4th axis. Now, in this particular case, I've actually put an automatic tapping head on the machine. The wider tool plate is one part of the MT package. Another part of it is an extended gantry, and that's done so that these heads have full table coverage. The SmartShop MT includes a standard vacuum table that all the SmartShops have. So that's a 6-zone, it's a universal type table, it has a T-slot feature for special fixturing. Now, something else that we've added to this is we put a mat here. And the reason we're using that mat is because in this application, we're using an oscillating knife and a tangential knife, and those cut down into that. So they cut through the material, cut into the mat, don't cut into the table. Vacuum is used to hold the parts. And of course, these are typically configured with a 10-horse vacuum pump. If you have a 5x10 or larger machine, you probably want an additional vacuum pump. Okay, there's some material. Let's put some material on here. But first, let's take a little break and let's go back into the office and let's talk a little bit more about what these technologies are and how they work. Then we'll come out here and you'll understand more what's happening. Okay, now let's look a little bit more closely at what we can add to the machine because of the expanded tool plate. This first head is simply a router head. It's just a small low horsepower router head. You could use it for light duty routing. You could also use it as a drill. It has variable speed, so that's one thing you might want to do. But so far we've really been talking about routing and what you do with the router bit. Sometimes there are materials that you want to cut on the machine that really can't be routed, and that's what these additional heads are. And these are actually tangential heads, and tangential simply means that as the cut's being made, it rotates. So the head rotates, and when you're watching the videos with it cutting, you'll actually see those knives turn. Now let's look at this, something like this material. This is called Ptex. It's actually used for snow skis. But if you notice, it's fairly thin, it's hard. What if you needed to machine that? What if you needed to cut a pattern like that out? You know, you could say the same thing about veneer if you were doing veneer marquetry, those kinds of things. How would you cut that? Well, a router bit doesn't cut it very well because you don't get the square corners. So we need another technology, and that technology is called Tangential Knife, and it's done with a tool just like this. Okay, so a knife like this mounts into a head, and then it has a pressure shoe that goes on it, and that's spring-loaded. Now what happens is, as this goes around the geometry, which would be required to cut, this head rotates it automatically, and it always keeps it at the correct angle for the cut, and that's called tangential cutting, and we'll look at that a little bit more detail. Okay, this works very well on materials that are thinner. Now, a real good rule of thumb is if you can take a utility knife and drag it through the material and it'll cut it, this technology works very well for that. All right, but what if you had a material like this that's soft, that you really can't cut with a utility knife, and it can be very thick? How would you cut that? Well, it's the same idea, except the blade's slightly different. Of course, it's longer. This time, instead of spring loading and keeping pressure on it, we actually oscillate the blade real fast up and down. So it goes around, it oscillates, it cuts it, and at the same time, the head actually rotates, so it's always at the correct angle to the shape. And that's called oscillating knife technology. And it's a 4th axis head also. This is a foam that might be found in a life vest. This is a foam that is used for the sign industry. It's a backer board that's a foam that's hard to cut. And then here's something as simple as styrofoam. But the oscillating knife technology works really, really well on things that are very difficult to cut any other way. So far the applications have been cutting applications. Now, sometimes we don't want to do that. Sometimes we actually need to do something like creasing. Now, a good example of that is let's say we're making a box, and of course we can use those other heads and cut the box out, but maybe I need to put creases in the box where it folds, and that's what this head does. So it has a creasing wheel, and once again it rotates 360 degrees so that creasing wheel follows the geometry correctly. You can take that to another level and actually put a knife in there and cut materials with it. So some materials can be cut with that. So all 3 of those are really similar technologies. Okay, so something else that's nice is these heads, all 3 share a common mount. It's a clamp system here, and they also share a common plug. So even if you get your machine equipped with one slide, these are plug and play, so you can use any of the different 3 heads. Let's take a minute and talk about tangency, because you hear that term thrown around all the time. What is a tangent head? What is a tangential axis? So let's talk about that. Tangency is really a term that relates to geometry, and it's a relationship in most cases between a line and an arc or a circle. So let's look at what those can be. If you look on the screen here, the first relationship is that with the blue line, they're not intersecting. The line does not intersect the circle, so they're not tangent. Okay? Now, if you look at the extreme, the red line, that circle is intersected at 2 different points by the line. They're not tangent either. The definition of tangency is if a line and an arc are tangent, they touch in one and only one point, and that's this point right here. And further, if you construct a line from that point to the center of the circle, it forms a 90-degree angle. That is tangency. Okay, let's look at how this actually affects cutting. All right, here's our knife, and we know that's oscillating up and down real fast. As it goes around the geometry, we want it to remain tangent to the geometry. So what's going to happen is this thing's going to rotate as it goes around. Not only is it going up and down, but it's turning, and that's what those 4th axis do. You see, then it turns inside of here. Then when you get inside of this cut, when it comes into a square corner, it raises up, rotates, goes back down, makes a cut, raises up, rotates, goes back down, and that gives you the ability to do square corners. Okay, let's go back to our drawing and let's look at tangency a little bit differently. Let's say I wanted to analyze the diameter of that arc. Now watch what happens. You see, as I move at different places around there, that white line represents a line that's tangent to that arc. That's what those heads do. So that's what the 4th axis and each of those 3 heads do. It rotates as it follows the geometry, and that's what allows it to cut. Now, there is a technology similar to this that's called drag knife, and sometimes people get that confused. And basically what happens is the way the knife is mounted, it basically rotates around and it kind of follows the cut. And the problem with that is you're limited to smooth curves, and you can't come and do inside a corner. So it's not nearly as good a technology as what's called tangential cutting. Remember, tangential cutting allows you to raise that up, bring it down, and give you the perfect square corner. So don't confuse tangential knife cutting with drag knife cutting. Okay, let's put this into some practical application. Let's make something on that machine using the oscillating knife. What I've selected is I've got a little dinosaur. It's actually, technically it's a triceratops that we cut out a lot. It's real popular. And I make it out of 1/2-inch material out of a 4x4 sheet. And so that's the material. And I bought that at one of the home centers. Now, it doesn't work, router bits don't cut it at all. It doesn't work very well with just tangential knife because it's too soft, but it works great with the oscillating knife. So that's what we're going to do. All right? This is the layout in VCarve Pro. These parts were just nested. The overall size is 48 by 48. I did that so I could use a 4 by 4 sheet. It's 1/2 inch material. In our case, it's styrofoam. It could be plywood if we were routing it. And these all get cut out. But let's think about what has to happen for the machine to actually do those shapes. 4 things are going on. It's moving in X, Y, and Z, your 3 axis, and those heads are also rotating, so that's the 4th axis part, and that's the tangential part. Now, how is that accomplished? Well, one way, a more traditional way to accomplish it, would be use a software program that, in addition to the X, Y's, and Z's and all those moves, also gives you angle calls, so it tells that head which way to turn. And that's fine, but that software is fairly expensive. So what we wanted to do was to create a better way to do that. One method, of course, would be have the G-code program to tell the control what angle to rotate those heads so that they tangentially follow it around. And that's fine, and that works well. It takes more sophisticated software to do. But we sit down with B&R Automation, who we developed a control that's on the SmartShop 2s with, and we said, maybe there's a better way to do this. Why can't we have the machine control do that? Because the machine control knows the geometry. It knows the arcs. It can establish what those angles are to maintain that tangency. And so that's what we did. So we developed a feature called Tangential Cutting internally in the control, and it does that automatically. And so what does this mean to you? It's real simple. Since the controller is doing all the angle calculations, it's on its own, the code I send to it doesn't have to have those. Now here's what that means. That means instead of a $6,000 program that might be needed to give me those angle calls, I can program that with VCarve Pro, which is $600. Or for that matter, virtually any other software. The angle calls are not required. The controller does that automatically. That's a huge benefit. And that's because of the relationship between Laguna Tools and B&R Automation. Oh wow, look at this, man. Wow, look at that inside corner, exactly like it. Oh, that's great. Let's get some of these pieces out. Neat, 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 neat. That knife blade is really, really thin. Excellent, excellent, excellent. All right, now we cut this with an oscillating knife. Look at the edge finish on that. Imagine trying to cut that with any other method. But here's the real test. These are little lap joints, and watch this. Those slip together. Perfect, perfect fit. Okay, I've almost got these together. Looks like I have the right number of parts. Pretty neat. I can assure you my grandchildren can put this together faster than I can. Well, that looks pretty good. You know, we've cut this low Triceratops out for a number of years at trade shows because it's always very popular, but we normally do it out of 1/2 inch plywood, and we've never been able to cut out anything soft like foam, and the oscillating knife gives us the ability to do that, so that's a neat little process. Let me show you something else I cut. Now, when we did the Triceratops, that's foam, so we used the oscillating knife. Now, materials like cardboard or veneers or things like that, we would use the tangential knife, and this is something I cut earlier. This is a piece of cardboard, and this is actually a rack for holding some parts in a certain position. So that cuts cardboard really well. Now, let's put some veneer on there and do some marquetry. Oh wow, look at that. Man, look at the detail. Wow. There's another one. Boy, it's unbelievable how thin and how sharp the curves are. So there's virtually no space in between them. But you know, to really get an appreciation of what this marketer is, check this out. That's what the finished product looks like. Well, I hope you enjoyed the video. I think you can probably tell we're really excited about these new developments. The MT series really adds a tremendous capability to our already successful SmartShop CNC routers. If you need more information, call our 800 number at 800-234-1976 or go to lagunatools.com. Thanks for watching.